Good evening, everyone. First of all, I welcome all the participants and viewers who are watching this video. And top of that, I would like to invite our today's guest, who is Dr. Arunava Majumdar. Today, he's going to deliver a session on applications of AI and machine learning in aerospace sectors. So, as we know, we are celebrating World Space Week 2024 is being celebrated from October 4th to October 10th, making an very annual celebrations of space science and technology. So, in order to celebrate this space science and technology, and right now, one of the most emerging technology is that AI and machine learning. Let's look into this session that how this machine learning and AI and machine learning algorithms can help you or your future to get into this aerospace sector. So I request Dr. Arunava Majumdar to take over the session.
Okay, so good evening, all the learners. Is my voice audible and screen visible properly? Okay. So our today's topic is an overview of the applications of the machine learning and the application of artificial intelligence in the aerospace sectors and in aerospace engineering. So basically, we will cover in the entire lecture these are the structure of my lecture components. Commonly used machine learning algorithms. Okay, that is the algorithms where which can be integrated with any um, means aerospace softwares and ML software platforms which are available for the aerospace engineering students and the professionals, and the integration of ML algorithms with the aerospace softwares and the top tech companies who are using and continuously making the innovations in different means their different components of their business with ML and AI techniques for the automation of the industrial automation and other things. Okay, to make the industry more sustainable or and to make the means meet the sustainable goals. So if we see the global market in aerospace and in artificial intelligence, so you can see that the market shares and the estimation of the AI market in the upcoming years are visible here. And you see that if we see the market share by the region, then North America, it has the highest market share of the AI industry, and then the last position it is coming as Middle East and Africa. So upcoming market forecast, we see that from 2023 to 2033, the size you can see 39.8% the market will grow. The CAGR, it is a CAGR from 2023 to 2030. So almost it is means 2030 CAGR, it is 43%, and the growth momentum it is continuously accelerating. And the market forecast, if we say the size, that is the market size in USD, it is 34.2 billion USD. It is predicted uh, within the year 2033. So let me ask you some poll questions. How will AI and the machine learning impact the aerospace and the defense sectors? So please you means write down the chat box your own opinion for this, and in that time we will continue with the lecture. So first of all, I will give you a brief introduction to what machine learning is. actually. So it is a branch of artificial intelligence. Okay, that focuses on different developing of different algorithms and mathematical and statistical models to compute and to perform different tasks without any outside instructions of the user or something else. So machine can automatically learn and make the decision. That is called the machine learning. So how the machine learning it will operate and it will make the decision. So let us um, take an example of a child. Okay, so how a child learns something. A child learns something. So you can see that after the birth, the child, he or she doesn't know anything. The no words, it doesn't have any knowledge of words, doesn't have any knowledge of recognition or to recognize anything as any object like fruit or like animal or like any other things. So day by day, he or she will learn means small things. Okay, very small things day by day. Keep learning. It keeps learning, and you can see in this child in this picture, it is learning the word, learning the different letters, A, B, C, D, and so on. So as the child learns, now it is going to develop. Now it is slowly it develops the recognition power. Now, if you just means to show the word, sorry, the letter A, so the child will now automatically understand that what is A or what is B or C, and after that, slowly it's recognizing as it will recognize the words, then the sentence, and so on. So how it learns? It is the system of learning. So learning is a basically we will giving the training to the child. Okay, the training of language, the training of learning objects or recognizing an object, exactly in the similar manner, we also have to learn a model. We have to make a model, AI or ML model, and we need to learn. We need to means pass different data through this model so that the model will understand that for which input what should be the output. Okay, a very basic situation I am explaining here. So after learning, the model will learn first and then the model will make some decision. So exactly the same thing it is happening in the machine learning algorithms. We are doing the same thing. Now the key concepts of in machine learning. So there is first we need some data. Without the previous data, we cannot learn any model. We cannot make some model as a learner, or we cannot train the model so that it can make some decision. Okay, so the uh, it is the foundation of ML, you can say. So there are two kinds of data sets. One is structured, just like a spreadsheet, where the serial numbers, different attribute names. Let us suppose I'm giving you an example like the mark sheet of a student, mark sheet of a section in a college. Okay, so different student roll numbers are written there, student names, registration numbers, and marks in different subjects. Everything are given in a very structured way. So that is called structured data. Okay, data also can you can say unstructured way you can also collect it. So just like random images or some text where nothing is structured, nothing is means structured like a serial number wise, or no attributes are given, nothing. We cannot understand anything from that data set, just some numbers or some different words or some different letters or something are given randomly. So that is called unstructured data. So in both the cases, machine learning algorithms are there to train the model. Okay, so then we need some algorithms. Okay, these are the methods, or you can say the methodology or process to identify the patterns of the data. If it is unstructured data, first this data should be in um, should be means structured. Okay, we should the machine will first make the data in a structured way, and then if the data is a structured data, then we can easily train the model, and we can make some decision based on the model training with the structured data set. Then we need a model. Okay, a model is nothing but a trained algorithm. After the training, now the model is prepared to make the decision. Okay, so whatever the now if you give some input, the model will give the output. Training. So far we already I have told you what the training is. So we need to pass the data sets through the model to train the model. Means if these and these are the attribute values, then this should be the output. If these are the attribute values, then this should be the output. So far we need to just like you can say, if I show you the picture of dog, that this is the picture of dog. So whatever the animal you can see looking like dog, you can automatically then recognize as yes, this is the dog. So it is just like that. So I show the picture, that this is the picture of dog or this is the picture of cat. Now the machine will automatically understand. If you just pass random picture to them, it can automatically detect which is dog and which is cat, which one is cat, just like this. Next, some features, the input variables, okay, used by the models, and labels the output or target variables. So input and output variables must be there. Is generally these labels are used in supervised algorithms, input and output things. Next, the types of machine learning. Generally, there are three types: supervised learning, unsupervised learning, semi-supervised learning is also there, but I'm not going to talk about that one, and reinforcement learning. Okay, supervised learning or training with the labeled data. Means if the data set is a structured data set or labeled data set, then we can train the model by using some input and output variables. Okay, so the examples are classification, regression. Unsupervised model, unsupervised, it is the example is the clustering. Means random data is given to you. You can divide the data sets, similar data set into different clusters. So you can see here, uh, this is the entire random data. First we show the model, and the model will automatically make three clusters. First cluster is the green points you can see. Second one is the blue points, and the third one is the red points. So red points, these are the similar types of data. Blue points, these also the similar types, and green, they are the similar types of data. So it made three different clusters to classify these three different models. Classifications are used for generally the data when the data set or the output outcomes are in categorical data set. Categorical means some you can say some binary data set, or some uh, pictures are given like dog, cat, or something. Okay, so if the input variables, let us say that if the nose structure or the structure of eyes, the structure of ear, the structure of face cutting is given, then this everything uh, will show a dog. This is the picture of a dog. So the input variables are structure of ear, the face cutting of the face cutting of the animal, the cutting of the structure of eyes of the animal. These are all the input variables. And what is output? The dog or cat or elephant. These are the outputs. So in that case, now if we supply any random picture to the machine to recognize whether it is dog or cat. Now machine can automatically understand that this is dog and this is cat, classify them. Okay. So that is called classification. Now, what is regression? Regression is generally used for when the outcome variable, the outcome data set is continuous, just like prediction of the rainfall. So, what are the input variable? We can say input variables, maybe the humidity, temperature, okay, wind conditions, cloud conditions, okay, all these things are the input variables, and the output variable is the amount of rainfall. Now this amount of rainfall, it should be in some numeric value. So the numeric value, we cannot say that what should be the exact numeric value. That is, if I say some dog or cat, it is a category, we can specify them. Okay, so either it is a dog or it is a cat or it is an elephant, like this. But in case of amount of rainfall, no one can say that what should be the amount of rainfall. This is called continuous data. So the prediction of rainfall, amount of rainfall in the next coming days or coming month, it should be, it is called the regression. So this kind of learning is a regression. Clustering, I already told you, if the dataset itself is unstructured dataset, then we need to first structure it by using some clusters, by separating the dataset through different clusters. Reinforcement learning, it is a feedback based case. Okay, so it takes the actions in the environment first, then received state updates and feedback. So it is a update and feedback type of cases. So I'm not going to discuss more things about it, because this lecture is not fully dedicated to the deep into the machine learning. So I'm going to the next one. So supervised learning, I already told you the regression and classification is there. These are the two cases. And regression, that is, you can see what will be the temperature tomorrow. Also, we don't know what should be the temperature, exact temperature, nobody can say. So classification, you can see the example is hot or cold. Only two categories I have divided, hot and cold. So whether tomorrow will be hot and cold. So there are only two outcomes, either hot or cold, nothing in between them. So hot and cold, simply hot and cold, either you can specify it in a binary data set like 0 and 1. Okay, there is no other number or no other numeric value we can specify for this. But the temperature, it may be different. It may be in an integer value. It may be some floating point value, that is 34 point something or like this. Okay, so nobody can say what should be the actual outcome. So that is why we have to apply the regression for this. Next, unsupervised learning. That is also I have explained the clustering. So this is, you can see the original data set is given like this, and we clustered this. We have made three clusters. The machine, actually not we, the machines will make three different clusters here. So one is this orange cluster, green cluster, and this blue one. So the similar type, these data set, these clusters are having similar type of data. Okay, so there are different k-mean clustering algorithm is there, which can make cluster, okay, by analyzing what data are similar type of data, and then it makes some clusters. Now we're uh, going deep into the algorithms, learning algorithms. First one, deep learning algorithms, neural network. I know that it is very common name today. There are two types of neural networks: artificial neural network and the combinatorial neural network, CNN. So yeah, this is basically deep learning. Deep learning. This neural network, we are talking about the ANN, or artificial neural network. It is used for both, that is supervised, classification and regression. For both purpose, we can use this ANN, or artificial neural network. So basically it is composed of some layers. Okay, some layers. As first one is initial layer is there or some nodes are there, and means the data set which we are going to pass through the model. Then some hidden layers are there. Then we will have some activation function, and the output layer is there. Okay, so based on these are layer based algorithms, so at first we need to pass the data set through this model, and then we give the training to the model, and then the model will automatically means predict that what kind of means output is there. If some unknown data set is passed, then what should be the output for that? Okay, but there are some limitations of this also here also. If the range of the data set, training data set is very small, let us suppose 1 to 10. We are all using the numbers between 1 to 10 and nothing else. Okay, so and if we for the means prediction purpose, if we use some data set which is very far from the original data set, then it may give sometimes the wrong answer or unsatisfactory answers. So what are the applications? Basically, image and signal processing and autonomous navigation, basically for UAV and drones. Okay, ANN is used. Second one is support vector machine or SVM. So it is a supervised learning model used for the data classification and regression task also. Okay, generally used for fault detection, that is in some aircrafts, quality assurance, classifying the there is a manufacturing defect means whether there is manufacturing defects is there or not in different aerospace components. So we can use this algorithm. Third one is decision tree and random forest, a very popular and means useful algorithm you can say. Basically, decision tree and random forest are not the same; they are different, but means first decision tree we need to learn, and then random forest it is a successor of the decision tree. Okay, so it is a tree-based model. Tree is a data structure basically in computer science. So data structure, it is a hierarchy process, means a hierarchy you can say. That is, if I can say that so that whether we are going to play or not. That is, we will go to play outside for today or not. This decision is based on different factors. What are the factors? Humidity is a factor, temperature is a factor, wind is a factor, okay, the prediction of rainfall it is a factor. So we need to first make some decision based on a tree, means we need to make a decision tree. That is, if we say that the temperature is very hot, then we can that is, let us suppose the temperature is between uh, 40 degrees centigrade. Then we need to identify whether the wind is, if the temperature is hot, then there are two successors are there. Now we need to analyze what is the humidity, whether any wind is blowing or not. If the temperature is low, we will, our decision is yes, we will go to play. But if it is hot, then we will classify it again in two manners: wind, the flowing of wind, and the humidity. If humidity is low, let us suppose we will go to play. If humidity is high, then again this is divided into two decision components, and so far it will make a hierarchy. Decision random forest, we have to, if the decision tree is very large, then there is some chances of error. So random forest, the decision tree, it is now divided into a small decision trees to make a forest, which is called the random forest, and which will means in this case the decisions will be more fruitful from the previous one decision tree. So the applications are predictive maintenance and operational decision making. Next, gradient boosting machine. So this techniques, it is a build models sequentially to reduce the errors. Okay, so the learning technique, that is sequentially built models. It is it. Okay, so general applications are performance forecasting and the risk assessment, is flight operations and some maintenance. Okay, also it can predict the fuel efficiency. Okay, emissions of the flights. Next, Gaussian process. It is a Gaussian process. It is a probabilistic based. Means you need to means learn some probability methods there. So used for regression and classification task both. Okay, and the answer applications are, it is the uncertainty. So basically, uncertainty, this word itself, it is a word when there's some probability is there. Uncertainty estimation, or there are actually two kinds of uncertainty: probabilistic and fuzzy uncertainty. So Gaussian process is basically the probabilistic uncertainty is there. We need to estimate the probabilistic uncertainty. Okay, there is system reliability, you can say. Okay, so predictions in critical aerospace systems. Okay, so we don't know whether the system will means when, at which time the system will face the failure. Okay, and after how many operations the machine, there should be a machine failure, that is out of control states, it is called in reliability engineering. Okay, so in that kind of analysis, so it is uncertainty, we don't know that is when the machine will fail. So to analyze this and to predict that time when the machine will fail, so this is very important. So for machine learning, it is very important to learn statistical methods. K means clustering. This is for unsupervised. I told you that this clustering system, it is to just means when the data set is totally unstructured and nothing, no attributes, no serial number, and nothing is given, just some numbers are given or some random words are given or something. We need to classify them into different clusters. So we need K-mean clustering algorithms. Okay, and the applications are anomaly detection, segmentations of operational data, CNN, convolutional neural network, what I already means uh, I told you just the in previous case. So it is basically detects the image. We are using the image recognition of this particular pattern when it is a specialized neural networks process. It is also a neural network, but it is a grid-like data. Means in a image, you can say that image is basically nothing but a matrix, a pixel matrix, every image. So basically, it is a matrix with different pixels. Okay. So whenever it is a matrix, so it creates some grids. We know that the cells of the matrix, there are many cells, and each and every cells, it represents some grids. Okay, so whenever this kind of structure is there, we use the convolutional neural network to recognize the image and image acquisition, satellite image analysis, image or satellite image recognition. So in this case, in this different scenario, we use CNN. Bayesian networks. Bayesian, it is also probabilistic. I already told you this is also used for the reliability engineering and the different decision support systems. Okay, so both Bayesian and Gaussian both are actually means Bayesian. It is based on the conditional probability. Some conditions are given, probabilistic structure with some conditional probability. Gaussian based on the when the data set, it follows the uh, normal distribution. Now come to different machine learning software platforms for aerospace. TensorFlow, I think many of them you already heard about. TensorFlow, an open source ML framework, so developed by Google. PyTorch, it is also open source machine learning library. It is basically for Python. Python is a very good open source means programming language, or you can say it is a library. There are different libraries for almost all kinds of ML and AI techniques you can find in Python. Okay, many tasks and many things you can. There are different libraries are there. You can explore the libraries. Okay, you can make any type of program in Python. MATLAB and Simulink. So far it is TensorFlow and PyTorch. This is free. MATLAB and Simulink. It is not free. You need to pay for it, but it is very structured. So Python, it is not that much structured way. It is different. Means platforms you need to use. You can use there. But MATLAB and Simulink, it is a very structured way. You can means make different models of the aircraft, and you can also any simulation structure you can also build in MATLAB in very easy and uh, comfortable way. And many structured and many things already are inbuilt. You can find in the MATLAB library also, but it is paid. Scikit-learn, Scikit-learn, it is also open source library for predictive data analysis. Also uses some means Python libraries. ANSYS, so the engineering simulation software. I think ANSYS you heard about already. That also it integrates the ML for enhanced the predictive capabilities. Machine learning algorithms we can integrate here. Azure machine learning, it is basically developed by the Microsoft, a cloud-based ML service, okay, for building and developing different ML models. Now, what are the things, means how the ML can be integrated and is used in the sector of aerospace or any engineering sectors? First of all, the predictive maintenance systems. So what is this? This system is the, you can say, to analyze the real-time sensor data, means suppose whether a car or any aircraft. Okay, when I already means discussed the failure, it is very important. We need to analyze the time of failure, when it will fail, when the machine will fail. What are the different conditions, or what are the different factors are there, outside factors which can make the system failure. We need to analyze that. Okay, so it is a very important thing for any aircraft. Okay, so the failure of any system means the aircraft, it is a completely destroyed, any aircraft. Okay, so any kind of whether it is fighter, whether it is passenger or anything, it will be, if anything happens completely, it is a complete destruction. So that is why the analysis, it is very important to analyze the error when what are the parameters. Okay, so that the machine can automatically detect that whether any failure will happen in future or not. And if it happens, then what are the different factors we should bother about, and we can reduce that factors so that we can overcome that particular failure. Okay, this thing not only it is applicable for the aircraft, for any kind of vehicles, for any kind of other mechanical system also, for machines, this thing is applicable. So generally the softwares use the TensorFlow, PyTorch, MATLAB, we can use these softwares. And in different research papers, okay, they are using different algorithms. Generally, by means exploring different research articles, the neural networks, random forest, gradient boosting, these are the algorithms are used for this predictive maintenance analysis. Next is autonomous flight systems. It is autonomous flight system. It is a robot operating system. So I think you know about already, it's heard about already. I think so. So autonomous, it is if the drone, basically we're talking about the unmanned vehicle, UAVs, and drones. Okay, so we need to drop any package, let us suppose, in a particular pre-specified means location. We need to destroy some target, okay, or we need to place some particular means we need to go or we need to go some particular place without any outer interference. It means that we will not control that one. Automatically, the machine will detect, okay, and automatically will detect the place where to land or where to drop the package, okay, or automatically can detect what is the target and what is the means to hit the target. So we any human, it is there's apart from any human, it is automatically when it is we need to make an automated system through the different machine learning algorithms, through some learning patterns or through some data set. We need to pass some data set. Yes, this is these the factors. If these factors are satisfied, then this is the target and you need to hit the target or you need to drop the package there. Okay, so it is autonomous fly system. We generally, and it is very useful, and the AI and ML techniques are using here nowadays. So algorithms are using reinforcement learning, CNN. Why CNN is used? Because of the image recognition pattern. Because we need to identify the particular place. So that particular place, of course, it is a picture of the place we were only having. So the picture of the place is having, then must we must recognize the picture whether it is similar to our previously trained picture or not. Okay, so that is why CNN is very important here, and it is generally using to develop the UAVs, navigate the UAVs automatically. Next one is flight path optimization. Flight path optimization is to identify the shortest path to reach to a particular location. Basically, a very common way I can say, or the most simplest way, the shortest path to reach a place from one starting point to an ending point or the destination point. Okay, so how you can so what are the why it is a necessary? Because means there are some obstacles we can face in between the UAV, means UAV path. Some obstacles are there, so you need to overcome that obstacles also. Okay. Also, there are path deviations. You can see some obstacles is there. You need to deviate there, deviate the path, but you need to reach the particular location. So after the deviation of the path also, after that, also you need to reach the particular place with the minimum amount of time or the shortest path you need to identify. So if there is obstacle, still also overcoming the obstacle, you need to find the shortest path. If there is no obstacle, so of course you can easily find the shortest path there. So in these cases, the machine learning or automated systems you need to develop in the machine. Okay. So here also the algorithms are using reinforcement learning, the gradient boosting machines, uh, genetic algorithm. So genetic, why it is genetic algorithm? Genetic algorithm, basically it is not a machine learning algorithm. It is evolutionary algorithm and used for the optimization strategies. Optimization means since we are optimizing the path here, minimization or maximization cases. So we have to use the genetic algorithms. There are some other this kind of optimization algorithms present, like swarm algorithms, like particle swarm, PSO algorithms are there. Okay, so many types of things are there. Softwares are using generally MATLAB, Simulink, TensorFlow we can use. Next, design and simulation enhancement. So aircraft design. Okay, so design of an aircraft. Basically, we need both. uh, the machine learning algorithms and the optimization algorithms both for this case for design. Okay, so neural networks you can also use to means the predict means what type of design is the suitable. Okay, means we need to for the design making there must be some data set, and this data set generally this kind of data sets are means outcome variable is continuous. So in that case we need to apply the regression, maybe linear or non-linear, or many regressions are there. Any regression model we can also use. So after applying the model, we can also means minimize that one to make the ultimate or optimal design of an aircraft. Okay. So the algorithms are used Gaussian neural network ANN generally. Softwares are used, that is OpenMDAO, ANSYS. The last one is quality control and inspection. It is very useful, and right now it is using basically this is practically right now the farmers are using in their agriculture. Okay, so pesticide, you know that pesticide. I'm just giving an example for that. The pesticide is very harmful to health. Previously, what happened that the farmers they are using the pesticide the entire the area of the crop the entirely they use the pesticides, they sprinkle the pesticide to the entire area or entire border or entire area whatever the crops are there of their land, which is so the unaffected or unaffected plants also they are using the these pesticides to the unaffected plants. So the plants which are already affected by some insects, that is also, of course, we need to means sprinkle some pesticide there. But we the plants which are unaffected, that also from there also we are using the pesticides. So that is why the entire land it is getting poisoned. So right now, by using this AI techniques, we are using the unmanned vehicles so that we can detect that which plants are they are affected by some insects and which plant they are not affected. So we can use only that particular affected place. We will sprinkle the means that is pesticides. So in that case, we can reduce this means toxicity level, okay, of the crop. So the softwares here, OpenCV integrated with the TensorFlow and Python is we can use. And for ML algorithms, CNNs, CNN is also used here because we know that this is also an image recognition or pattern recognition cases. CNN you must use. Also, and decision trees also we need to use. Combination of both also we can use. Now come to what are the different companies who offer the expertise in machine learning in aerospace sectors. First one is Boeing, the largest company you can say, and ML applications they are using as a predictive maintenance and the design optimization of the aircraft to enhance the efficiency through the data driven design. Airbus, it is also a global leader in aerospace. Okay. It employs ML, okay, to streamline the operations, logistics, okay, and to implement different technologies. And they're using the flight optimization, supply chain management. Okay, so supply chain management it is not means related to the aircraft structure or something. It is basically used for that. It is a management thing. So to logistic management or inventory management, okay, and stocks and like this, they basically for profit of the company means maximize the profit or reduce the cost of the company. SpaceX, okay, they are using the rocket design, using the ML for rocket design and the launch optimization. We know that SpaceX is using that is uh, means there. reuse of this. They are basically believe in the reuse. So the you can see the launch optimization is very important for the SpaceX company because they're using this reuse or the space vehicle, whatever they are sending, they want to reuse them. So means they need to re- return back to the that particular space to the Earth, okay, safely. So that is why this optimization there is how to launch properly very important for them. So also they are using this. Of course, they have to use the ML techniques for that to recognize the launch pad and what are the different thrusts. Okay, Lockheed Martin, they are using the autonomous vehicles to develop drones, unmanned vehicle systems, and advanced simulation techniques also. GE Aviation, especially they are making the aircraft engines. So they use the ML applications in engine monitoring. Okay. There is sensor data they are using, and then they perform some ML technique to means predict some outputs. Predictive maintenance, since it is an engine, so of course predictive maintenance is very necessary for this company. Okay, and Raytheon Technologies. So this is they're using the ML applications in threat detections, autonomous operations. Honeywell Aerospace, they are using avionics systems to improve the flight system with intelligent data processing. In-flight systems enhances the passenger's experience. So they're using ML techniques. Okay, Dassault. So already, I think many of you have means heard about this company because India is now means purchasing the Rafale aircraft from this company. So simulation and modeling, they are also using ML techniques and the product life cycle management. Okay, so product development, data driven insights, they are also using the ML techniques. ANSYS, so simulation enhancement and design optimization for the aircraft design optimization, they are using it. Now, if you were interested in to learn or to dive deep into the machine learning in aerospace engineering, you can see these books. Okay, the machine learning and data mining in aerospace technology, which is a Springer publication, and this is CRC Press publication. CRC Press, or general publication name is Taylor and Francis, the aerospace and associated technology. So I would prefer these two books to you to learn if you are interested. Any questions you can
Yeah.
ask me now.
Yeah, thank you so much, sir, for your wonderful presentation. And you have nicely highlighted that what are the softwares required, that if they want to propel their career towards AI or ML. And you have also discussed some of the key factors, that what are the key companies and what are the areas they are actually working on. So thank you so much for enlightening on those particular area. And we have few questions. So let me take a few of the questions. So there was some question that how is ML assist in aircraft design? So can you just enlighten them that how we can utilize?
Voice is not audible.
Mm. So am I audible right now?
It's some glitch is there.
Okay. Is it better?
Yes, now it is better.
Okay. So the question is that how is ML assist in aircraft design?
How ML is used in aircraft design, right?
How if they are specialized in aircraft design, how they can utilize ML to work on those things.
There's a glitch in voice. I can't hear the voice properly.
So shall I use chatbot?
Yes, yes, yes. Please paste the question in the chat box so that I can. Okay, how ML assist in aircraft design? Okay, so for this, mm, I can show you a data set. Let me just find a data set of. mm, Scotland.
All right. Meanwhile, I request all the viewers and participants to uh, buckle up your place because we
Okay,
are
so
yet to share our feedback form with you all because without feedback form you can't get your certificate. So please stay tuned with us until our team share the feedback form with you, right? And if you have any further questions, I request all of you to drop your questions or queries in the chat box. Yeah.
okay, so hello, am I audible?
Yes, sir, you're audible. Sir.
Yeah, so the how ML assist, I can't find the data set right now. Okay, so I'm just giving a little bit explanation for this. So in aerospace, first you need some aerospace data set for this. So let us suppose you need to have some different attributes, means some speed, okay, and thrust, okay, usage of fuel or something, and what is the means let us suppose that outcome variable is the um, either MTOW or the use of fuel, or the means the usage means that is what is the fuel it consumes. This is the output variable. So depending on, so different input variables are there. Input variables are, let us suppose, the wingspan, the speed of the aircraft, okay, the height of the aircraft, maximum height, okay, the weight of the aircraft. These are the different input variables. So for different data, there is some output. The output variable is only one, which is the consumption of fuel. So this data, if this data set is available, so we can analyze this data and we can use some machine learning algorithm to develop an structure of the model, means optimal structure, or we can make a machine learning regression equation, okay, so that if we give any kind of input, that is, this is the wingspan, and this is the means the weight of the aircraft, this is the maximum height of the aircraft, then what should be the outcome means what is the but specific means consumption of fuel for that particular design of the aircraft. That will, the machine learning automatically gives you this particular outcome. That is, if you give make this kind of structure of the aircraft, then your fuel consumption will be this. Now, for this structure, now we can apply the optimization method to this particular design equation to analyze that what should be the optimal structure of the aircraft. That is, what should be the length, what should be the means height, what should be the maximum height of the aircraft, everything, so that we can make the aircraft in such a way so that it will consume the minimum fuel consumption. So like this, we can design a new aircraft, a novel aircraft for different types of attributes. To minimize the weight, you can use different types of aircraft. Okay. For minimum oil consumption, you can use different design of the aircraft like this.
All right. I think, sir, you have also clarified one of your students' question that there was actually another question how machine learning helps in fuel consumption or fuel efficiency optimization. You have also answered for that as well. Okay. Now, moving to our next question is that, so the vacuum cleaner robot is also working on ML or not?
Can you please
I have got the question in the chat box.
vacuum cleaner robot is also, yes, yes, sure, sure. Vacuum cleaner robot is also working on the ML, of course. Vacuum cleaner robot, it is especially it if you means implement some ML algorithms for, you can say, the image recognition. Okay. So in vacuum cleaner, basically in general vacuum cleaner model, we you can say is that means if it is a very general model you purchase from the means market, that specifically does not use any ML algorithm because they are using some sensor, and that sensor is just implemented. If it hits some target, then it will return back like this. So it doesn't require any kind of ML algorithm. But without, if you can modify this vacuum cleaner to vacuum cleaner robot, so that if any obstacle, so you want that any specific or particular obstacle the robot will not hit. In case of general model, the robot will hit in any obstacle, and if it hits, then the sensor will recognize that it hits, then it will turn back, or some vehicle or wheel structure is like this, it will turn back to the another side or like that. But if you implement some ML algorithm, you can also train the model so that do not hit this particular target, do not hit that particular object. Okay. Or especially if suppose means the bed. Okay. So the inside the bed, if you want to, there is inside the bed, there is very much means dirt is there, and your hand is not reaching. So you program that one in such a way, whenever it detects that is some in it is the bed inside. Okay, it will, if you can make some CNN, that is convolutional neural network, to identify, that is it can automatically detect, yes, this is the bed and this is the inside of the bed, and it will go and automatically clean the inside bed. No need to means um, you don't need to force that machine, or you don't need to operate that machine for your own. The machine will automatically detect that one and clean that position. Similarly, not to hit something. If something, some glass object is there, you can also program that this is the entity for glass, this is the object of glass. So if the machine detect that this is the glass object, it will not hit that one. So this kind of things you can means implement ML algorithm in vacuum cleaner. I think that already have came into the market. I think I have clarified that one.
Yes, sir. So we have one more question. I have dropped the question in the chat box. That how can we use ML in satellite communications?
Okay, satellite communications. Satellite communication system, you can use this ML to detect some threat. Detect some threat means, let us suppose that you means are communicating to somebody else. Some in the means there are communication. There are basically in the means communication system or this communication theory. There is a means this communication, whatever you are saying, that is transmitted. Okay, first it is encoded. Whatever you are saying, it is encoded. Then it is transmitted. Then it is decoded, and then it is visible to the reader. Now this transmission system, some hacker or somebody, they can easily means detect it, or if they decode the means your word or whatever you are saying, if they decode it, they can easily understand, and this kind of things happens. Okay. So in communication systems, so some hackers or something, some outside threat is there, so which can detect this and easily they can take out the information. So to means resist this, you can use some ML algorithms. If the machine can detect in between them these some outside threat is there, automatically the communication will be stopped. Okay, automatically it will be stopped. So you don't understand whether any outside threat is there or not, but machine can detect. So you can use some ML algorithms to develop in the machine that if these are the input variables, you can train it like this. So if this happens, then this is the output, this is the outside threat. If this happens, this is not outside threat. So you can train the model. Then the model will automatically detect is this the outside threat. So cut the communication will be uh, just abolished there. Okay.
Yeah. So, in according to that, we have one more question. How to identify the correct algorithm for the right situation?
Yes, for doing this, you need to first understand what machine learning algorithms are, and for what kind of task you need to use which kind of algorithms. There are different books and different learning materials are available in the internet. So I already have explained these things in the means slide also. Supervised learning, unsupervised learning. If the data set is very structured way, use the supervised learning. If it is unstructured data, so we need to go for the clustering then. Okay, if the outcome variable is continuous, we go for the regression. If the outcome variable is categorical, we will go for the classification. So there are different techniques. This is I cannot say this in a single word. It is uh, very large thing. You need to understand the data set first, and then you need to understand the algorithms, and then you can say that yes, this algorithm is used for this.
All right. And we have a last question of today's session, that does ML can be used in flight controls in drone?
Yes, yes, flight controls and drone. That is also I already is also used basically. And in slide also it is given. There is in UAV and drones. There is unmanned vehicles are there. So we are going to somewhere where the means the place means the our destination point is already specified previously. Then by using the image recognition, we can use that one means we can reach the machine can reach there without any human interference. So we will learn the machine in such a way so that if this is the pattern of the image, then you need to hit the target. If this is the pattern of the image, do not hit the target. Okay, so we need to learn the machine in such way. Similarly, for dropping or shipping some uh, means in logistics, if you are going to ship or if you are going to transport something to different place, you can use the UAV there. And if it is means you can mention some particular place to drop. And if this is the scenario, suppose we are going for the high altitude. Okay, so high altitude, there are some, you can see some means rescue team operation is there. For rescue team operation, you need to first give some transport vehicle there, means UAV, for some important medicines or food you need to transport. So how can, if it if don't no need to means operate the system, just you learn the system in such a way. In high altitude there is no human. Okay, so only human is you can see the humans there. Okay, or see the particular structure is there. If the humans are means help or something, it is written there, or some structure there or they have already used. Okay, if that kind of structure, the machine will learn, yes, this is the structure, or these are the humans on the high altitude sectors means, then we can drop the shipment there. So you can use this in that way. Already these kind of things are using in UAV sectors.
Okay. So, one last question from my side. So, what challenges are there in applying machine learning to or into this aerospace sector?
Uh, what challenges are there in applying machine learning in aerospace sectors? Basically, challenge aerospace means softwares are already there. Okay, already there are some softwares. Specifically, they're dedicated to the aerospace. You can also find in MATLAB aerospace toolbox are there. The challenge is how to implement the AI algorithm to that toolbox also, which is already the packages which is already available in the internet. So you need to implement the ML techniques to that package. Okay. So that is the main challenge. Means you need to use some learning algorithms there, how to implement the algorithms and how to implement that algorithm to that particular already structured model is there. So you need to change the code, how to change the code so that the previous model is also intact and also you are going to embed the code to that particular previous model without affecting the previous one. That is the challenge.
So, yeah, thank you so much, sir, for clarifying all sort of queries that our participants were shooted in this
Okay,
session.
thank you very much.
So,
Thank you.
thank you so much for your time and
Thank you
giving
very
in
much.
wonderful sessions on application of machine learning as well as AI techniques, especially utilized in aerospace sector. So I request all the participants that those who are watching this video or those who have taken part on this particular 1 week program. So requesting all to drop your, don't forget to fill up this feedback link. So before you leave the station. So thank you everyone and keep in touch with InnovaWorld for more such wonderful sessions. Thank you everyone once again and see you on tomorrow's session. Thank you, sir,
Thank
once
you very
again.
much.
Thank you.
Thank you. Good night, everybody.
Good night.